Hello there, Ella here, and today I'm breaking down for you the muscleful effect. So the muscleful effect is the short name for what is known as the postprandial muscle protein synthesis refractory period, which I think we can all agree is a bit of a mouthful. Essentially, it's the observation that when you eat protein, muscle protein synthesis, or MPS, is increased for about 2 hours, but then returns to normal. What's interesting is that even if amino acid levels in the blood remain elevated, MPS does not. It also takes about 4 hours before your muscles would respond to even more protein, which researchers call the refractory period. It was hypothesized that once your muscle cells had had enough protein, they wouldn't accept anymore, essentially because they were already full, hence muscle-full effect. This is actually really well established in the literature, and it's the reason that most nutrition programs include a protein meal every 3.5 to 4 hours. Recently, Dr. Sawan at the University of Illinois noticed that the previous research had all been done using whey protein and in some cases, amino acid infusions. Now, both of these sources are considered very pure, and so it's easy for the researchers to use. But they also appear in the blood much faster than any natural food could. Dr. Sawan and his team wanted to find out if the rate of digestion affected the muscleful effect. In December 2019, the Journal of Applied Physiology released a research paper investigating how a slow digesting protein, like whole milk protein, affected MPS over a 5-hour period. To do this, the researchers fed 9 healthy men a specially tagged whole milk protein and observed their MPS rates over a 5-hour period. Now, the process for how they actually created the tagged amino acids is actually pretty cool. First, they took a lactating cow and fed it specially tagged amino acids, which then appear in its milk. From its milk, it then was concentrated into a milk protein concentrate, fed to the research subjects, and then they tested their muscles over a period of time to see how much of those amino acids actually made it into their muscles. What they found was that a slow digesting protein source not only triggered MPS, but kept it elevated for over 5 hours. Compare this with whey protein, which only kept it elevated for 2, and this is actually pretty significant. It challenges the view that we need to eat protein every 3 to 4 hours. Now, don't go running off yelling that we need to eat one huge ass meal every day and that's all we need to get jacked. It's a little bit more complex than that. What this study shows is that a slow digesting protein can keep MPS elevated far longer than we previously thought. But that's it. Just because we can build muscle for longer doesn't mean that we end up building more of it. To show you what I mean, I'll need to explain something called the area under the curve. If we graph the MPS for whey protein versus whole milk, we would probably end up with something that looks a little like this. If we calculate the area under each of these, we would then end up with the total muscle built. This is called the area under the curve. What we still don't know is whether whey or whole milk protein would have the greatest total growth. It's possible that whole milk builds protein for longer, but whey protein builds more in total, just in less time. Similarly, this paper only looked at the effect of a single meal. It's possible that having frequent whole protein is even more beneficial than just one. So what can we actually learn from this study? Well, first, if you're going to spend more than a few hours without food, you're better off eating a slow digesting food source. This is a bit of a no-brainer, but it's nice to see the research agreeing with common sense. It also means that eating less frequently will still likely support you gaining muscle mass if that's your thing. We don't know which is more optimal just yet, but if you keep eating less often, you're probably going to be okay. Overall, I think this is a really fascinating study, and I think it warrants a lot more investigation. Until we know more though, I would offer you this advice. If you're trying to lose fat, this study provides evidence that eating less often is perfectly fine for preserving your muscle mass. If you find that eating less frequently helps you feel full with the same amount of calories, I think you should keep doing that. For those of you seeking to gain muscle, I would caution a little more skepticism, at least for the time being. The consensus still says that eating more frequently is better, and whilst the effect is likely minor, until we know more, my recommendation is to keep eating a protein meal every 4 hours. So you may be wondering, why should you care? If I've just spent all this time going through a research study only to tell you, hey, don't change anything, why does it even matter? And that's actually a really fair question. At the end of the day, just because I don't think that there is enough evidence for us to change what we're doing just yet, at least until we find out a little more, that doesn't mean that I don't think this research is fascinating, and I think you should too. Ultimately, there are two big things that really fall out of this that I think challenge a lot of what we think we know around protein timing. The first is that this study demonstrated that a fast digesting protein like whey shuts down MPS, but a slow digesting protein doesn't. Now, we don't know exactly why, but I'd hypothesize it probably has to do with the amino acid concentrations in the blood. Something like whey or, an amino acid infusion dumps all of these amino acids into the bloodstream really, really quickly. And it seems likely that the muscle cells are picking that up and responding quite strongly, but then some kind of threshold is crossed and it stops. Versus if we drip feed those amino acids in via something like a whole milk protein or a slow digesting protein, maybe like a whole meat even, then it never really crosses that threshold. And that kind of asks a bunch of questions, like, well, where is that threshold now? Is there a certain amount? Is it the rate that they enter the blood? Is it a total concentration? Does that mean that what triggered it to stop from whey might be very different for, say, a casein or for a meat product? We just don't know, but those questions are fascinating. The second reason, and this is definitely the one that's getting me most excited, is that most of the studies that we've looked at maximum protein intake for muscle growth in a day have largely used whey protein in measuring that. Now, we've already demonstrated that when you use whey protein, there becomes a limit where your muscle stops responding. So it's entirely possible that our understanding of how much protein you should take in a day to maximize muscle growth could be completely wrong. Again, I'm spitballing here, but I would hypothesize that if you were to use a lower digesting protein source, say casein or whole meat, then the maximum protein intake that you take there may actually be much, much higher. Again, I'm not saying it is, but it's possible. What's really cool about this is that it kind of matches the observations that most of us have had, that having a higher protein intake, well and truly above the 1.6 grams per kilogram that is recommended as a maximum, has had beneficial results far beyond what they're suggesting. I think this space is something that's really interesting for us to keep watching in the future. Whilst in the end, I don't think this study is going to change the world overnight and that we should change anything in how we're doing our training or nutritional protocols. But I do think it challenges a lot of what we think we know and a lot of the dogma around protein intake and what's optimal for body composition. I think this is a really fascinating space for us to watch in the future. And I think as we continue to keep progressing down this over the next few years, we'll see a lot of growth and development in what our training protocols and nutritional protocols should be. Overall, I hope you found this study as fascinating as I did, and I would greatly appreciate a like, subscribe, and share with your friends if you enjoyed. See you in the gym. Bye.